30 years on a ground gunnery range separates a functional heavy bomber from a static aluminum shell. In 1956, the United States military sent a Boeing B-29 Superfortress to the China Lake Naval Gunnery Range, the weapons range at what is now Naval Air Weapons Station China Lake. The assignment was to serve as a ground test target. By 1986, 3 decades of ballistic testing, environmental exposure, and systematic cannibalization had stripped the aircraft of its operational integrity. The recovery objective was to rescue the remaining structure and stabilize it for non-flying static display. The primary constraint was disassembling a compromised spaceframe without triggering a total structural collapse. This was not an anonymous scrap airframe. The physical configuration and original data plates matched the United States Army Air Force's serial number 4469729. Museum records identify this specific bomber as T-54, serial number 44-69729, and record it as having flown at least 37 combat missions with the 875th Bomb Squadron, 498th Bomb Group. By 1986, the machine on the desert floor bore little resemblance to a combat-ready aircraft. Its value lay in the identity still traceable through records and plates, not in any remaining operational completeness. At the China Lake site, the recovery crew faced a practical salvage assessment rather than a clean factory inspection. They had to judge which parts of the bomber could still carry load, which areas had been weakened by years on a gunnery range, and which parts had simply been removed during military cannibalization. Public accounts confirm the aircraft was dilapidated, weathered, and stripped, but they do not document a fastener-by-fastener engineering report. The safest reconstruction is that the team treated every major lift, pull, and support point as suspect, until the surviving structure proved otherwise. That distinction narrowed the handling limits. Missing parts left visible voids. Projectile strikes and exposure could hide deformation around skin, frames, and rivets. The team had to read the aircraft through surviving load paths rather than through standard bomber assumptions. The range years produced a slow, architectural dismantling rather than a single crash pattern. The investigators cataloged missing engines, a hollowed-out cockpit, and absent defensive turrets. Every missing component shifted the original center of gravity and altered how the remaining skeleton rested on the desert terrain. The assessment required recalculating the weight distribution of the hollowed-out B-29. Standard factory lifting points designed for a fully loaded bomber could no longer be trusted. A crane sling placed over a compromised bulkhead would instantly crush the upper fuselage. The recovery team had to devise a completely new handling geometry based purely on the 1986 state of the damaged structure. The operation began with a hard contradiction. A documented combat survivor reduced to a fragile, hollowed-out shell resting in the dust. Extracting it required moving a massive, heavy bomber structure out of a restricted ordnance zone and transporting it across the country. The initial assessment phase closed on one fact. The space frame was still standing on its own landing gear, but its internal strength reserve was unknown. The next problem was not identity. It was how to begin physical work without turning that balance into failure. Arid environments create a preservation paradox for aviation materials. Dry desert air slowed moisture-driven decay across large areas of aluminum skin, but heat, wind-blown grit, broken windows, missing covers, and old impact damage created localized hazards. The same conditions were harsher on non-metallic parts. Fabric control surfaces, tires, seals, wiring, and cabling were destroyed, cracked, degraded, or left unusable. The metal structure could not be dismissed as brittle simply because it had sat in the desert, but the aircraft could not absorb rough handling like a complete, maintained bomber. This rigid state directly constrained how the assessment team could approach any disassembly plan. A heavy bomber is held together by thousands of steel bolts passing through aluminum spar fittings. When moisture is absent, these two dissimilar metals do not rapidly corrode at their contact points. However, the relentless desert winds introduce a different mechanical limit. Microscopic sand and silica particles are driven continuously into every exposed crevice, open structural joint, and threaded bolt hole across the airframe. The constant air movement effectively sandblasts the exterior while packing the interior voids with abrasive material. At the fastener level, ordinary removal could not be assumed. Some bolts could be worked free, others might have to be drilled or bypassed under aircraft repair judgment. What mattered was not that every connection was permanently fused, but that no primary joint could be treated as predictable after decades of exposure, stripping, and range damage. The team then triaged the junctions. Only connections required for transport had to come apart while others could remain assembled. Forcing a distorted wing joint or seized fastener risked tearing irreplaceable aluminum around the wing roots, so time was traded for structural survival. The next gate was provenance. That proof had to come from surviving identity marks and service records before the physical touch plan advanced. A post-war aerial tanker exterior can mask the framework of a combat veteran. By 1986, the volunteer recovery team from Lowry Air Force Base, operating under the moniker Mel's Misfits, faced an airframe stripped of many primary visual identifiers. The structural and equipment changes associated with conversion into a B-29 refueling tanker had altered the wartime configuration. Post-war fittings, missing combat equipment, and weathered markings made the original identity harder to read from the outside. The recovery goal therefore required a careful identity check before the aircraft could be treated as an irreplaceable combat veteran rather than just another range target. Confirming combat provenance on a severely stripped airframe requires matching internal data plates against heavily archived Bomber Group mission logs. The exterior paint and squadron tail markings had long since eroded away under the intense solar radiation of the desert, rendering external visual identification impossible. Investigators had to rely on surviving identification marks and records rather than exterior paint alone. The surviving identity trail confirmed a Boeing B-29-60-BW associated with the military serial number 44-69729. Public accounts place its acceptance into service in early 1945, while the museum identifies the aircraft by serial number and wartime service record. This numerical match provided the historical lock. The verification elevated the work from target range salvage to the deliberate recovery of an irreplaceable artifact. However, securing the historical identity immediately shifted the engineering focus to the physical integrity of the remaining aluminum shell. A heavily scavenged interior forces recovery teams to prioritize exterior structural survival over internal completeness. The public record confirms that the bomber was missing or degraded in wiring, cabling, wartime bombing equipment, fabric control surfaces, tires, and other systems. What remains less certain is the exact condition of every internal frame and bulkhead before recovery. The safe working assumption was therefore conservative. Protect the surviving major load paths first, and treat missing internal equipment as a restoration problem for later. The planned disassembly therefore centered on protecting the wing to fuselage load paths while treating missing equipment and post-war changes as restoration problems for later. With identity locked and the remaining structure judged movable, the problem narrowed to separation. How to remove the major wing assemblies of a 141-foot airframe for highway extraction. Breaking down a 141-foot heavy bomber wingspan for civilian highway transport creates a strict geometric limit. A rigid structure of this size cannot navigate standard road widths, negotiate highway curves, or clear overpasses intact. The volunteer recovery team from Lowry Air Force Base faced the absolute requirement to remove the major wing sections from the 99-foot fuselage. They had to achieve this separation without destroying the attached structure needed for future static display. The disassembly sequence demanded extreme precision under severe mechanical constraint. Operating with hardware inherited from decades of desert exposure, the crew had to remove the major sections without relying on a clean factory teardown. Each support point had to be chosen for the aircraft as it existed in 1986, not as Boeing had delivered it decades earlier. The rigging problem became one of balance, patience, and restraint. Support the sections, free only what had to be freed, and prevent the old bomber from twisting under its own dead weight. Once the massive wings, tail assemblies, and central fuselage were successfully separated and stabilized, rigging teams loaded the disconnected sections onto flatbed trailers for the move to Colorado. The overland logistics operation moved the dismantled aircraft roughly 1,000 miles from the California range to the preservation site. This extended transport phase introduced a new hazard profile. Road vibration, loading cycles, and repeated tie-down checks all added stress to an already damaged skin and joint network. For a bomber that had spent decades as a target, the danger was not a single dramatic failure alone, but the gradual opening of weaknesses that already existed. Upon arrival in Colorado, the immediate operational objective shifted from extraction logistics to structural stabilization. Reassembling a compromised structure required closing the visible gaps left by years of target range damage and weather exposure. The volunteer crew could not treat the aircraft as a flyable restoration. Instead, the first Lowry effort focused on making the bomber whole enough for safe static display. The sheet metal work drew on aircraft repair practice and battle damage experience, but its goal was stabilization, not a return to airworthiness. A tear in aluminum skin interrupts local stress flow and can create crack points at jagged ends, so mechanics reduced that risk where appropriate by stop drilling crack tips, trimming damaged metal, and riveting reinforcing patches or replacement sections over weakened areas. The teams then stabilized warped wing fairings, patched punctured bulkheads, and reattached the 99-foot fuselage to the wingspan, restoring local continuity without claiming factory structural strength. The measurable result was practical rather than flight-worthy. The heavy bomber could stand safely on its original tricycle landing gear without external cradles. The aircraft was no longer an abandoned desert target, but a stabilized airframe actively undergoing targeted preservation. With the space frame stabilized on its gear, the next threat came from outside the aircraft. A military installation closure forces an abrupt change in institutional custody and geographical risk. Lowry Air Force Base formally closed in 1994, and that closure drove the bomber's transfer away from the Colorado base where volunteers had begun its rescue. The mechanics had stabilized the immediate physical deficits, but the aircraft remained on loan from the National Museum of the United States Air Force. An artifact of this physical scale could not simply remain behind as base property after the installation shut down. The loan arrangement required a new institutional home. The decision centered on finding a museum capable of accepting a very large, non-flying heavy bomber and continuing the restoration already begun at Lowry. The Museum of Flight in Seattle and Washington became that receiving institution, with the aircraft remaining on loan from the National Museum of the United States Air Force. Relocating the aircraft necessitated executing another sectional highway transport to move the dismantled components across multiple state lines. This administrative and physical transfer formally closed the initial rescue chapter and initiated a new era of strict institutional control. Upon receiving the bomber in 1995, the Seattle engineering team initiated a comprehensive physical audit. The new assessment recognized that the earlier field expedient stabilization methods were sufficient for temporary survival, but they did not meet the rigorous standards required for permanent museum curation. Seattle's phase carried the work beyond exterior survival toward documented museum completeness, while keeping the aircraft clearly in the category of static display. Executing this restoration demanded intensive labor and strict forensic discipline. The team had to identify missing wartime equipment, degraded systems, damaged sheet metal, and post-war alterations, then rebuild or source parts against wartime documentation where possible. Public accounts describe rare armament, radar, navigation, communications, bombing equipment, hydraulics, instruments, flight controls, oxygen systems, interphone systems, engines, wiring, and cabling as major restoration challenges. That is the safer claim. A comprehensive museum restoration of systems and structure for static display, not a documented return to factory-specified torsion resistance. The restoration teams also addressed hidden surfaces and enclosed areas of the airframe. Exposed aluminum, joints, and cavities required cleaning, inspection, and corrosion control suited to a museum aircraft that would never fly again. These treatments reduced future decay risk, but they did not end the need for monitoring. The transition from a hollowed-out range survivor to a supported static display airframe was well underway. Then the bomber's size created a local hazard. An aviation museum operating at full capacity rarely has immediate indoor hangar space for a 141-foot wingspan, so the aircraft had to be staged outdoors on the museum campus while awaiting a final exhibition pavilion. The relocation protected the aircraft from administrative abandonment but changed the environmental threat profile. Seattle rain and ambient moisture put unprotected aluminum at risk, especially at seams, joints, and repaired areas. So the conservation problem became shielding the bomber from weather without creating new moisture traps. In 2011, the bomber was cocooned in heavy white protective shrink wrap while it awaited a permanent exhibition home. That wrapping visibly protected the aircraft from direct weather exposure, but any sealed cover on a metal airframe carries a conservation trade-off. Trapped moisture can become a hazard if not managed. Public sources confirm the shrink-wrapped outdoor staging, but they do not document the specific use of active humidity machines, desiccant arrays, or internal monitoring ports. By 2016, the Museum of Flight's covered aviation pavilion was completed and open to the public. The B-29 was unwrapped and placed under that roofed outdoor gallery for long-term display. Its exterior markings reflected the T-Square 54 combat identity, but the move into the pavilion should be understood as a major preservation milestone, not proof that the airframe was forever fully preserved. The aircraft now transitioned into a state of permanent static display. That condition introduced a structural problem different from flight. In the air, the wing structure carries aerodynamic and inertial loads in ways that change constantly with speed, weight, maneuvering, and turbulence. A non-flying airframe resting permanently on its landing gear faces a different problem. Gravity becomes a constant load, so tires, struts, wing attachments, lower frames, repaired joints, and corrosion-prone interfaces require periodic inspection and support as needed. The restored internal structure now serves a museum purpose, keeping the airframe stable while curators watch for slow deformation, moisture intrusion, and renewed corrosion. The recovery of the heavy bomber is complete in the curatorial sense. A combat aircraft that endured target practice, cross-country transport, and outdoor staging now stands under cover with its provenance secured and its restoration limits acknowledged.